Hey everybody, today we'll do another math problem. And today we will do problem in linear algebra that is basically a linear algebra problem that contained an augmented form. In other words, the problem is already in an augmented form. Last time I showed you guys using the software in the computer how to transform an equation from an equation to an augmented form. This one is actually already in augmented form. All we have to do is is to use the Gaussian elimination to solve the problem, but we have to convert that to row echelon first, to row echelon form. So we can start by doing a method that this is actually in this book, linear algebra. So it's called A Modern Introduction to third edition by this person, David Paul. So we can start. The title for this topic is counting operations. Counting operations. Counting operation. An introduction. An introduction. An introduction to the analysis to an analysis of a logarithm. Algorithm. So technically, this is what the topic about. Okay. So basically, what they say over here is, let's examine an augmented form in the form of now that I have this, let me just erase this, right? Because this is just a topic. So let's say that we have a form of like this, A, then we have a bar, and then here we have B, right? And then let's say that equal to, for example, something, right? And the book says, the book actually said, let me just write it down here. So consider the augmented matrix, right? Actually, it is singular, so just like that. Okay, so, and then they give us a problem. It says, if the problem is in this form, A bar B, right? Close that, and that is equal to is equal to 2, 4, 6 bar, and then 8, close the bracket, and then we have 3, 9, 6, and then we have 3, 9, and 6, and that is equal to 12, actually 12, right? Technically, this is an equation. Each of these is an equation, so that's why I am saying equal, right? This I is A, and this I is the vector form of that matrix, right? So the left side is is A, which is the augmented form already, but this side is the vector form. In other words, this is the value of each equation, what equals to. But again, after we solve the equation, we can check that, right? So that makes sense. So now the bottom equation is -1, and it's 1, and -1 again, and then here is 1, right? Right? So now we can actually put in practice what we learned last time, right? And try to solve this problem by making this, let me be clear, because I don't want to confuse anybody. This is not what I'm intending to do. We want to turn this one, and this one. We want to turn those into ones. That is the main focus here. And I want to turn this, let me make it clear. I want to turn this, and that into zeros. Okay, so I don't care about what is up here and what this is. I don't care at the end. I don't care what I get in this side or I get on this side. What I care is about this to be ones and this to be 0, and that will be what I'm looking for, right? First, right? So this is what I'm looking for before I start solving. Let me just be clear. I want to make this ones and want to make this zeros, and before I start solving the problem, right? Or in other words, let me make more clear. Before I start getting the values for X, Y, and Z. Remember that I have an X, Y, and Z in this case. I got an X, I got a Y, and I got a Z, right? Okay, so now that we have this augmented form, right? What we can do is try to make this row 1, right? And my first number that I'm looking for is this one. Make that 1. So how can I make that number a 1? This first one in the corner. I need that pivot point. I need this to be 1 so I can start doing this diagonal reds over here and converting those into 1s. So how do I do that? All right, so, okay, so let's divide everything by 2, right? So I have a 2, 4, 6, and it's equal to 8, right? That is basically what this is. This is an equal sign in here, but I have a bar, right? If I divide everything by 2, I got a 2 divided by 2, that divided by 2, and this divided by 2, right? So this is equal to 1, 2, 3, and 4. See that? All right? That will be my first step, right? My first step. So now that I have it that, in that form, so I divide everything by 2. Now I can rewrite it that just changing this rod into this, right? So rod number 1, rod 1 is already transformed, right? So this is rod 1, rod 2, rod 3, right? So I said that first equation was 1, 2, 3, bar 4, correct? Then I get, and then the 3 stayed the same. The second stayed the same for now. 3, 9, 6, negative 1, 1, negative 1. And of course, here I gotta do 12. I gotta do 1, right? Okay, what is the second step, right? The second step, I want to make it this a 0, right? I want to make this a 0. How can I make this a 0, right? That would be the question, right? So to make this a 0, remember I have a pivot here. I have a pivot point here. So I have 2 choices here. Either I can add rod 1, and rod 3, or I can actually try to make this a 0 first, and then try to make this a 0. But if I want to make this a 0 first, I have to multiply this by I have to multiply this road by negative 1, right? So if I multiply this by a negative 1, right? So let me do this. Let me put it in green, right? So I'm multiplying that by a negative 1. Row 1 is multiplied, I get it multiplied by a negative 1, right? Let me be clear. Okay, so row 1, I multiply by negative 1 and add the result to row 2, right? To row 2. In other words, the operation will be the following. Will be 1 will be negative 1 times row 1, negative 1 times row 1, plus add that to what? Add it to row 2, right? So the result of this or negative one, the row 1 multiplied by a negative 1, I'm going to add that to row 2, which is this one, right? Okay, so if I have that, then I can actually write it here. I can actually say, okay, I can actually, okay, so, no. So it's negative 3. It's negative 3. Right? So it's negative 3, right? So, okay, so when I do that, so negative 3 times 1 is what? Negative 3 times 1 is what? It's a lot of stuff going on here. See how I was making a mistake already? So you got to be careful. So, because I want to get rid of this. Actually, I want to get rid of this first, right? To get rid of 3, to get rid of this here, I got a 1 here, I got a period point, so I got to multiply this, the whole row, right? To get rid of this. That will become a 0, right? That's my first goal. So negative 3, negative 3, so negative 3 times 1, right? The first row stayed the same. The first row stayed the same. Again, the first row stayed the same. I am just multiplying it and add it to row 2. So row 1 stayed 1, 2, 3, 4. Okay? Now, I am adding that result to row 2, right? So negative 1, negative 3 times 1 added to 3, well, negative 3 and 3 is equal to 0. Okay? I got my first 0, right? Negative 3 times 2 is negative 6. Negative 6 added to 9 is positive 3. So this becomes 3. This becomes a 3, right? Negative 3 times negative 3 again, times 3 is negative 9. Negative 9 added to 6 is negative 3, right? So this is a negative 3. Negative 3 times 4 is negative 12. Negative 12 plus 12 is 0. Right? Now, I just write and then I just rewrite everything in the bottom. Alright? So I got a 1. Let me do this in green. So I got a 1, negative 1. I got 1. And I got 1, negative 1, I'm sorry. Negative 1, and I close that. Okay, so now I have this 0, but now I can actually say, okay, how can I make this 0, right? Because I still have to make this 3. I have to make these 3 greens zeros. So I gotta get rid of this, right? So how can I get rid of this to make that 0? Well, if you see that I have something in common here. So here I got what? I got this row and this row. If I add them together, I can get rid of this. No problem. Right? No problem. I think I can do that. Right? So if I do that, what is going to happen here? So if I do that, so now I just add R1 plus R2. 3, I'm sorry. 3. R1 plus R3. Row 1 plus row 3. Right? So when I add those, then it's going to be what? It's going to be, this is going to become a 0. That is going to become a 3, correct? Yes, 3. So let me just rewrite everything back here. This is a lot of work. So this is, it's quite a lot. So here, so I am adding row 1 and row 3. So that will be 0. Row 1 stays the same. 1, 2, 3, 4, right? And this stays 0, 3, negative 3, right? And this, and then this plus this is what? 0. And this plus this is 3. And this plus this is 2. Right? Now, and this plus this is 5, right? So 5 here. Right? So now, okay, so here R1 plus R3, but I am adding the result in what? R3, right? So here this is 0, and this is 4. Okay. Now, if you see this, what else can I do to get rid of this? I still have to make that a 0, right? So what I can do is multiply. See, the problem is here. If I try to use row 1, this, I will be adding a number to this. I don't want to do that. If I use row 1, it's not going to work because that will add a number to 1. I want to this, which is going to make either a negative 1 or a 1. So I don't want that. I want this to stay 0. So to do that, I multiply this by a negative 1. If I multiply row 2. So row 2, okay, let me just do it. Okay, so 1, right? Multiply negative 1, multiply row 2 plus, and add the result to what? Add it to row 3. Because I want to get rid of this, right? Okay, so in this case, I get what I get when I do that. All right, so I do, the first one stays the same. 1, 2, 3, 4, and I think I made a mistake. That is 3. That's 3. I hope I did not make another mistake. That's 3. Okay, 1, 2, 3. Okay, so that's just like that, right? That's the first equation. I have an extra 4 here. I don't need that. Be careful with this. Okay, so I got that, right? Now that is row 1, right? I need to do row 2 multiplied by negative 1 and add to row 3. So that is 0, of course. So I put 0 in there. And the second one is 3. But I am multiplying that, right? So I am multiplying that times that is 0. And that times that is negative 3. So negative 3 added, so this stays 0, right? Negative 3 Negative 3 and 3 cancel each other out, and then I got a 0 there. Right? Now, negative 1, again, negative 1 times a negative 3, that is a positive 3. Positive 3 added to 2 is going to be equal to 5. Right? Now, this is still 0. This is a negative 3 here. And this is a 0. Right? Now, this is a 5. Okay. Now, this is a very, very interesting problem, the way that I have it, because I have a 3 here, I have a 3, negative 3, I have it, and I have a 5 here. So how can I get this to make this equal to 1? See, I got to make this equal to each of those two ones. I got that 1 already. I got that. I don't have that 1. I don't have that 1. I need to make those 1s. The best way to do this at this point will be divide each one by the reciprocal. In other words, divide it by this by 1 over 3 and divide this by 1 over 5. When I do that, this 3 will cancel out with that one, with this 3, right? And of course, will also cancel out with this one, but I don't care about that one. This 5 will cancel out with, of course, with this 5 and with that 5. And this is equal to 1 here. Make sure I am doing clear this. That is a 1. This is a 1. And this is a 1. I'm just putting those numbers over there so it makes sense for the people seeing this, right? Now, this, all I have to do at this point is rewrite this and put it as like this, right? So I have 1, I have 2, I have 3, and I have 4. I got 0, I got 1, I got negative 1. Remember, this is a negative 1, so I got to make sure that I count for that sign as a negative 1. And this is a 0. This is a 0. And that is a 1. Then, of course, I got to put this 1 here and 0 here. Now I am ready to solve. Now this is in the form is called echelon form. Why is it called echelon, row echelon, right? So why is it called row echelon? And just let me make sure that I spell that correctly, because it's a kind of some spelling that, okay, row echelon, right? So reduce is called reduce. It's called reduce row So, okay, so row echelon form, right? So this is called row echelon. Why is it row echelon? Because I got 1 and diagonally, got 1, 1, 1. 0, 0, 0, and again, I don't care about whatever here, I don't care, right? So that is the row echelon form. Now, in that case, In that case, the next will be the substitution in place of the elimination, right? Of the Gaussian elimination. So the substitution can be done here because, see, I can start solving this using see, this is very important here. This is what analytical skills come from, right? So if this is x, this is x, y, z, x, y, z, well, I can just say 0, x. I don't even have to, but if I can, if I want to, I can say 0x plus 0y plus z, y is z because it's 1z, there's 1 there, is equal to 1. All right, so what is the value of the first equation? Well, this is 0, this is 0, z and z is equal to 1. This is the value of the third equation. I'm sorry, I think I said first equation, but I meant to say first solution. Okay, so C is equal to 1, right? Now, C is equal to 1 at this point. How can I find the value in this equation? Well, at this point, it's already a piece of cake. Why? Because I already have 0 here. I have 2 variables, right? But I have 2 variables here, but I know the value of C already. C is 1, so guess what? Z is equal to 1. So all I have to do in this case will be 0x plus y minus a z, right? Minus a z, z, right? Minus z is equal to 0. See? Now, what is the value of z? The value of z, this z, is 1. So all I have to do here is y minus 1 is equal to 0. If I do that, this is equal to y minus 1 equal to 0. And if I add 1 on both sides, y is nothing but 1. Now I have the value of y and z. Now I can take those values and plot this in this equation right here, right? Because this is equivalent to this. Either way is going to be the same thing. Either I use this or I use this because I reduce it, I am going to get the same thing. Because all I did with the equation number 1, I transform it by dividing by 1. Now, if I use this equation, it's going to be the same thing as if I use that equation to solve for x. I have the value of x and c, y and c now. Now I need to solve for x. So let's do that. Let's do 2x. I see that is equation 1 right there, right? 2x plus 4y plus 6z equal to 8. Okay, so now plot the values, right? So I get 2x, y plus 4 times 1 plus 6 times 1 is equal to 8. Solve for those values, right? Solve for those values. Solve for x, and you get 2x plus 4 plus 6 equal 8. Add those 2. This is equal to 2x plus 10 equal to 8, right? subtract 10 on both sides, and I get 2x is equal to negative 2, and divided by 2, of course, on both sides. And I see that x is equal to negative 1. X is equal to negative 1. Okay? Now, let's test it with this equation. If x is negative 1, that would be negative 1. That would be plus 2. Right? Plus 2. That would be plus 2. And then this and this will be 5, right? Because c is 5, and then the negative 1 is still equal to 4. See that? And we can actually test that in this equation that is already transformed, the one that I use that is already transformed because I divided by 2, right? So we can check it if that is true. What we can do is use this equation right here, this one. So we can say just to check if that is right. So we say that x plus 2 plus 3, x plus 2y plus 3z is equal to 4, right? That's what we say, right? Okay, so now the values of x is negative 1, the value for y is 1, the value for z is 1, and it's equal to 4, right? Now, look at this. I got negative 1 plus 2 plus 3 is equal to 4. 5, right? So I got negative 1 plus 5 is equal to 4. Add those two together, I got 4 is equal to 4. And that checks. That's all I need to know right there. Okay. So I can check it using any of these equations. If the solution is true, I have to get whatever is in this column on this side, right? So, okay, so that's it for this problem. I can check in this one, but still it's going to be the same thing. See, in this here also, what is the value of x is negative 1. Negative 1 times a negative 1 is what? Positive 1. Okay, what is the value of z? What is the value of z? It's 1. That would be 1, that would be a negative 1, and this one will cancel each other out, right? And what is the value of y? The value of y is 1, so it still is equal to 1. You can check in any of these equations, it will be the same. You will get the same values, right? So that's it for this problem. In this case, because technically the books try to show something that is important to learn, I guess. When you have an augmented matrix, you have it in the form like this. So you have it in the form like this. So A and then B, small b actually, right? Now, when you have something like that, you can translate that into something like this. So let's say that you have a bracket like this with a bunch of, right? So then you have what? You have A, but that A is like A is row 1. So row 1, let me just be quick in this. Row 1, column 1. So row 1, column 1, right? Then you got the next one is row 2. I'm sorry, it's row 1, column 2. So will be A1, column 2. See that? And then will be A1, column 3, and so forth, right? So what the book does is try to show this, right? A bunch of dots like that. And then it shows V1, V2, and so forth. So V1, right? And then of course here will be row 2, column 1, row 2, column 2, and then row 2, column 3, dot, 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 B2. How did it show? Yes. Then at the end, they got a bunch of dots like this. And they got row N1, row N2, and so forth. So they got A1, so that would be A1, actually no, A3, okay, row N1, okay, so row N, you got like this, row N, row N1, and then of course, I think they got a drop in every single one, yep, like that, and they got an A, N, let me do this in green so you guys have a little more understanding, I guess, of the one. And then and then they have A and then they have 3. And then of course here they have B. They have a B. I believe they have a BN. Yep, BN. So that will be the augmented matrix type. So in this case, let me just make that in green. That will be a 3. This will be a 2. And this will be a 1. Right? So just to make it clear, the black numbers are the rows, the green numbers are the column. Row 1, column 1, still row 1, column 2, row 1, column 3, row 2, column 1, row 2, column 2, row 2, column 3. And then, of course, row up to row n, whatever, whatever numbers of rows and columns you have, that's how you do it. So, okay, this has been the video for today. If you like this material, just give me a like, share the video, and subscribe to the channel, right? Thank you for watching.